You're listening to Coding Blocks, episode 24. Subscribe to us and leave us a review on iTunes, Stitcher, and more using your favorite podcast app.
And visit us at codingblocks.net where you can find show notes, examples, discussion, and more.
And send your feedback, questions, and rants to comments at codingblocks.net. And follow us on Twitter at codingblocks, or head over to www.codingblocks.net where you'll find all our social links at the top of the page. And with that, welcome to the Coding Blocks podcast. I'm Alan Underwood.
I'm Joe Zach.
and I'm Michael Outlaw.
That happened so fast.
Yeah, I decided to let mine draw out a little bit.
I'm messing with you guys.
I should do it in a southern accent. I should have Alan say it for me.
Wait, I don't have a southern accent.
Oh, that's a good one.
All right, welcome to the show.
All right, yeah. So first up, we want to start a little bit of news. So first off, we want to thank you guys. We got some more reviews: Helium Filled Stamp, Kick and Bach, and Mackie Merg. We also recently discovered that there's other reviews that we hadn't seen because they were on international versions of iTunes, including
not just
one
America
that maybe compared Alan to a former U.S. president. So that was pretty awesome, and so we're gonna have to gather those names up and say thank you. But we appreciate it.
Yeah, and just so you guys know, we're actually experiencing some of the woes of the Stitcher reviews. I don't know why, but they seem to intermittently work. And we got some great ones, but we can't mention them because we can't see them right now.
Right. Also, wanted to do a quick update on our New Year's resolutions.
Nah.
No.
Wait, there was Outlaws. All right.
So I'll give you
Well, I was
guys...
still waiting on Alan to do the course on it.
Well, I've got even more depressing news. So I've been working on a roguelike in C#, just like a fun little game. And I just found today this guy, the Stuff with Stuff blog that we've mentioned before, he did the really cool maze thing. He just open sourced his C# roguelike like today. So that's a big bummer.
You backpedaling? You going to switch?
I might. I mean, I'm sure his is way better than mine. So I'm going to have to find that out. But thank you, Reddit, for ruining my night.
So mine, I started doing this Angular, course. And what I found was I was getting really frustrated because all the Angular stuff out there is just like, oh, you want to show, like, I don't know, some pictures of phones. Like they have this phone cat example. And it's like, man, that's not real world stuff. I want things that people actually deal with, logins.
Man, you know how many people use phones?
Right. But, I wanted to get a little bit deeper, so I started, looking at, all right, well, we need a login system. Okay, well, now that you have a login system, how do you log down portions of the UI? And
oh, my God.
And so, yeah, it was a rabbit hole, right? So I started going further and further, and I think
come back out of the hole there, Alice.
No, I don't think so. I think that this is actually valuable. So I think the course that I'm going to be putting together is actually going to be a combination of, and this is what it really looks like.
It sounds like it's going to be a full-fledged authentication permission role system, plus there might be some JavaScript and Angular sprinkled in there.
You got it. It's a little bit of everything.
Hey, good summary.
So yeah, I'm actually going down that way, and I've made some progress. I've actually made some decent progress.
But the real question, though, is it Angular 2?
No, you know what? That's really frustrating, and I might switch gears because there was big news that came out that we should discuss. We didn't even have in the show notes.
That's right.
Threw a bomb in there.
Angular 2 is actually being built with TypeScript.
What?
Yeah. We'll leave a link in the show notes for that. But so
little joint venture there between Microsoft and Google.
I mean, seriously, if anybody out there has a Windows phone, which I had done about a year or so
all five of you.
I mean, dude, it was ridiculous. You couldn't get YouTube on your phone because Microsoft and Google were battling back and forth.
I don't think that war has stopped.
No, it hasn't, but that's what's really weird. Like, they are literally working together on Angular 2.0, and it's being built with TypeScript. So that's really cool stuff. So when they release the developer tools for that, I may actually switch over and play with that. But we'll see.
Yep. Also, wanted to mention this week we are doing a book giveaway.
Yes, please.
Yes, the book that we're giving away is a book that we've talked about quite a bit. It's the Design Patterns book, The Gang of Four.
I've heard of this one.
Yeah. So it's an older book. It's a great book. And so what we're talking about doing is basically if you come by the website and leave a comment on this episode, which is www.codingblocks.net/episode 24, just drop a comment in there, say something, and one of you will randomly win this book.
Now, wait a minute. How do I know that this book is of any kind of value, right? Is this like, the 18th printing of this book?
No, I think there's only one edition ever. I think we talked about that last time, right?
And just to be clear, this thing looks pristine. Like this
looks like he's never read it.
Yeah, I don't think he's ever opened it. So yes, he spent $50 and it could be yours.
That's right.
So, no, the book's in great shape.
So we're giving away Joe's money.
Yeah.
Here today on the podcast. Yes,
that's how much we love you guys.
So how do you get the book?
Just drop a comment on www.codingblocks.net/episode 24 for a chance to win.
Yeah, tell us why you want it.
What if Jack Bauer wins?
And Jack Bauer wins.
Chloe, get on the floor.
I need a port on the firewall open now. Send it over to my screen.
Do you think Jack Bauer gives high fives?
What?
This is almost like a Chuck Norris question.
I don't think he does.
Hey, wait. Hey, have you guys ever done that? Go to Google and type in "find Chuck Norris."
No.
Oh, if you do that and then you hit "I'm feeling lucky," well, it used to be an "I'm feeling lucky." It's not there anymore. It's a nice little Easter egg. Everybody should try it when they get home.
All right.
So, anyways,
find Chuck Norris. Okay, so of course I got to do this now. Like I can't.
Yeah. All right. So let's do it.
You can't like throw out something like that and then just tease it.
All right, so find Chuck Norris. And then if you click on the first link.
You got to click on the first link.
Man, it's not there anymore. See?
No, it's there.
Yeah.
Someone captured it.
All right, so
you can't tell it. You can't. People have to experience this, man.
But then they're just going to hear us like randomly laughing and they're not going to understand why.
But they could go home and do this.
All right.
Here, I'll tell you why I'm laughing. The suggestions. That's why I'm laughing.
Well, no, I liked it. Even the red error message.
Pretty nice.
Let's just say, okay, fine. So, as Alan said, go to Google.
No, you can't do that.
I'm giving them instructions.
Okay. All right.
Calm down.
Spoiler alert.
Go to Google, find Chuck Norris, and like Alan said, click on the first link, and then read from there. And you got to read the whole page. There's all kinds of things like read the left nav too. There's some good stuff there.
Yeah. So
all right. So back to the lecture at hand.
Yeah. Here we go.
Wow.
So
no tangents here.
We got a great Twitter question from Adrian Capel, who's at Capel Codes a lot. And he asked us about good examples of delegates. And what I found when I was kind of like looking for one is that
politicians.
I didn't really like any of the examples, and I also couldn't explain it very well myself. So that was kind of the kicker for this show.
So, yes, we're talking about delegates today.
All right. Everything you never wanted to know. I mean, always wanted to know.
Mm-hmm.
Yeah.
Oh, and I think it's worth noting we're mostly talking about C# because what does Java not have?
Delegates.
Yes, we couldn't find them.
Oh, this isn't JavaScript?
JavaScript kind of has it. We'll get into that later.
We'll get to that. Mm-hmm. All right. It. So, I guess we just want to start off with like a high-level overview.
Let's do it.
Sure.
All right, cool. So, if you haven't seen delegates before, it is kind of hard to explain, and it's something a lot of newbie programmers kind of stumble on, and experts too. And there's a lot of reasons for that. It is complicated. There's this kind of long, weird history and evolution. So a lot of things that you kind of Google for, you end up finding just older ways of doing things. And there's these weird words like event and delegate, and a lot of times you'll see like generics in there, and it's just kind of weird. So hopefully we can kind of simplify things and focus on the simpler way of explaining this, and hopefully you guys will get something out of it. So I guess at a high level, it's just a type-safe function pointer, which really just means that you can pass methods around as parameters. So I can have a function that takes in another function and does things. And what that means is that I can, at runtime, take in and execute different methods. So,
well, let's put it like this. Let's say that you want to have a method that does some work, and if there's any kind of error, maybe you want to allow the caller to pass in their own error handler that you can call, right? How's that?
Yeah, I like that.
Right. So this gives you the ability. This is a way for that caller to be able to pass in their method, right? That you can then call.
Right, and you can execute, and then you can handle the kind of the problems that arise, just like you said. So absolutely, and also delegates are a really big part of the .NET language, or the CLR and C# specifically. And the reason for that is that they're really the core of the .NET's strategy for closures, callbacks, and events. And they've got some really cool tie-ins and some things that we've already talked about, like strategy design pattern and observer design pattern, which you can read about in the book that we're giving away.
So before we go past this, though, let's make sure that everybody actually understands when we talk about a closure. And I think we might have mentioned this in the previous episode, but a closure is when some method can actually access variables outside itself, right? So that's a big thing. So it doesn't have like its own defined scope that it can't reach outside of.
Right, and we talked about this before the show a little bit. I think the best example, at least for this episode, of a closure is just the for each, right? The link for each, it takes in like a lambda expression, which is just a delegate, and it can access variables that are defined other places in that function. Right?
Yeah, and when he's talking about for each, he's not talking about actually when you say for each and then var whatever in something. He's talking about the actual link statement where you have a collection and you say dot for each.
Yep. Another example would be like the where or any of those dot whatever extensions that take the funky little X arrow stuff. Those are all examples of delegates, and they're all examples of things that can kind of reach out to the parent scope to draw things back in that get executed in the context of that method call there.
Yep. And then when he talked about callbacks, we actually also discussed this because I wanted to know where he was when we were talking about it. So the callback, basically what he's saying is when you call a particular method, as one of the parameters that you are calling in that method, you are passing in the function that you want that method to then execute when it's done doing something. So a callback is usually, hey, after you're done doing some arbitrary chunk of code, run this other method that I want you to run at the end of it. So you see it all the time in JavaScript. And so that's
great for async, right?
Yep, perfect for async because, when something's done with the server, whether it succeeded, failed, whatever, you want it to run some piece of code to carry on the next step. And then the events, somebody want to take that one?
I guess not. No.
Okay, nobody was prepared for that one. Yeah.
Events are kind of interesting because they allow for easy extension of classes without, or extensions of behavior without actually having to subclass. So if you've ever seen things like methods like on before save and on after save, or on before render, on after render,
on button click,
button click, yep, things like that. So those are all basically these kind of hooks where you can hook in additional behaviors and do things without actually having to subclass, and that's really useful because a lot of times you don't even necessarily know all the things when you're designing these classes that you want them to do, and you want people to be able to kind of extend that behavior without mucking around with your stuff.
Yep. So I just wanted to make sure we cleared up what we were talking about there. So now we can move on.
Yep, and really a big part of this too is it's the real heart of Link. And I think it's like a key part of the kind of C#'s awesomeness. Because
delegates predate Link, though.
They do, but they are a necessary component. So there would be no Link without delegates. And there's no Link in Java, so not really anyway. But anyway, just think it's awesome. Well, we're going to dive more into this later. Also, I wrote down here in my notes that it's expressive and dynamic functionality in a dynamic world. And so what that means is it just... it lets you kind of treat these methods.
In a static world, you said.
Yes, in a static world. This is the best world.
Yeah. Well, you said dynamic, but you meant static.
Yes.
Expressive and dynamic functionality in a static world.
There we go.
Yeah. All right. And what I mean by that is you're basically taking in a variable that points to a method. And it can be different things at different times. And so that's just really powerful and easy to read, too. And the last note I had here, we actually kind of mentioned this, but it allows for easy and controlled extensions. So you can kind of add these little hooks like on before something, on after something. And what's really cool about that, and ties into episode 7 where we talked about the solid principles, is this is a great example of the open-close principle where your objects, if you seal them up but still have these extension points, these events, then you are, by definition, open for modification open for extension, but closed for modification. So you can't change my behaviors, but you can extend them, which is really cool.
Yep.
Yet another way to implement the template pattern.
Absolutely.
Yeah.
All right. So let's dig into these delegates.
All right.
So we've already said that they were type safe function pointers, but do we really go into like why we need that? I don't think so.
Not yet.
So let's see. What would be a good? Well, I mentioned the example of like if you wanted to have a handler, if you want to have like an error handler to be called, right? You need to be able to pass in that pointer. You need to be able to pass in that method, but without a method pointer, without the ability to point to that method, right? This is a horrible explanation.
And this is part of the problem is the delegates are definitely hard to explain.
Well, here's an easy one, right? Like, let's say that you have something that, and we'll see later, and I think Outlaw even put together an example of an addition type delegate, right? Let's say that you have some sort of UI that has the ability to take in two numbers, and then let's say that you have three buttons that say one's add, one's multiply, and one's divide, right? So now what you do is based on whatever button click happens, you're going to pass in one of your methods. You might have three methods. One's going to be multiply numbers, another one's going to be add numbers, another one's going to be divide numbers, right? So you could then you might have those and you could pass them into a method based off what the button click was, right? So you have some math class out there that you're going to call and you're going to pass these things that have the signature of int with a return int, right? So now you can say, hey, they clicked add. I want to pass in my add method. But the only thing it cares about is that the signature is correct, right? It has a number, and it's going to return a number. So that's one way with what we're talking about is the type safety of it, and that's why it matters, is because all it cares about is the signature. As long as you pass it a method in through that, the pointer is going to work.
Yep, and the person who built that button, they had no clue what you're going to be using it for, right? They just had, they knew that when it clicked that they needed to do something that you instructed them to do.
Well, more importantly, they didn't know how you wanted to do it. They just know what they wanted back.
Mm-hmm. Right.
They knew like, hey, you're going to need to pass in a couple values here, right? Let's say in the add example, right? You're going to need to pass in a couple integers, and I'm going to expect back an integer. I don't care how you get there.
Yep. And also, with this example, it's a great example. I wanted to mention the other part of the definition there, which is these are type-safe function pointers with a built-in iterator. And so what that means is in this button example, unbeknownst to Alan, I could take his library and add sounds to it. And so when you click that multiply, not only does it run the event that he expects, but I can also play a certain sound effect for multiplication and a different one for add. And these are things that I don't have to touch his code at all. I can just kind of extend that behavior. And this built-in iterator knows how to go through and call each event that it needs to call.
Yeah, respond to. That's actually one of the cool things. So I'll take it one
now
step
we're kind
further.
of jumping ahead into multicast delegates there, right?
It is multicast delegates, and so that's kind of one of the cool things, right? Like, let's say instead of the example where I said you had three buttons, add, multiply, and divide. Let's say instead you had one button, but you had checkboxes next to each one that you wanted to happen, right? So you had a checkbox next to add, checkbox next to multiply, and then one by divide. What you could do then when you hit that button, you click it, behind the scenes it's going to say, hey, add the add method to my event handler. Now add the multiply, and now add the divide. And then that way when that fires off, it will, sequentially go through them in the order that they were added.
I guess though, like, and maybe this is just my own thinking though, because when I think of callbacks versus events, I typically don't think of callbacks as there being many of them, right?
Right.
Like events, I definitely think, hey, there could be multiple handlers that are going to get invoked, right? So multicast delegate. But in the case of a callback, I'm typically thinking, hey, there's going to be one method that's coming back.
Correct.
So yeah,
it's an important distinction. It's really hard to talk about delegates without talking about events, but events are really like a special type of delegate. And so I wanted to give a quick example of a delegate that isn't an event, and basically that ties into the strategy pattern. And the example I've got here is like if you wrote like a chess simulator, And your chess game might take any number of different strategies. That might be the Bobby Fischer bot or the Kaspersky bot, or just something that makes random moves. So, totally taking the UI out of the situation. When I create this game, I could pass it basically an algorithm to use. And one way of doing that would be to have a delegate that takes in the board and returns a move, right? And then I could basically pass in a method that knows how to do that, and I could swap that method out at runtime based on what the player selects.
It sounds like we're going to apply this to like every pattern so far.
Yeah,
we've already said strategy. We've talked about open close. I mentioned template.
Yep. The mediator pattern also comes into play.
Oh, we mentioned observers.
So the key thing that everybody needs to understand is all it really is when we say it's a pointer, you define this delegate thing, right? And you give it a method and you say, run this. So, like, D1, we'll call it the delegate, right? You pass in the method add. Well, you're actually going to say D1 open close paren, and it's going to run that add method you gave to it. So just to clarify so that you understand. So when you're passing these things in that we were talking about earlier, you're literally passing the delegate. It looks like a variable, but really what you're doing is you're passing a reference to that method that can just be executed. So...
It's like variable methods.
That's exactly what it is.
So let me be a little bit more verbose then. So let's say, going back to the calculator example that you brought up, right? So let's say that we had a delegate with a signature of int, and we'll call it an add handler, and it takes in 2 ints. So it returns an int, but it takes in 2 ints. And in your variable example, so you create some var, and we'll call it Adam, and then you would have some handler that already implements a method with this signature, so you could then create a new add handler and pass in the method that implements that. Well, I don't want to say interface, but yeah,
it's the signature.
Well, that's signature. Thank you.
So
signature
if you had exactly what you said, so let's think about it. Let's break it out into its pieces then. In the simplest scenario, right? The very first thing that you might have is you might have an addition method. So you're going to have a public int addition open paren int number 1, comma int number 2, right?
A public delegate int. Oh,
no. This is the method. This is the method we're defining, right? So this is your thing that does it. And that's the signature. So it returns an int because we said public int, and then the 2 parameters inside were int1 and int2, right?
Okay.
So that's what we've got. And then going back to your delegate, take it from there, how you would set up your delegate.
Oh, so then you'd say the delegate signature would be public delegate int and add handler, and then in parentheses int x int y.
Yep. And then, so what you did is you just lined up the 2 signatures of those. That delegate signature now matches the method signature.
But the thing is, just to be clear, though, going back to Joe's multicast example, is there could be multiple methods that all implement that same signature.
Yep.
That could be assigned to this delegate.
Correct. So your delegate would be something more generic, and then if you had a multiply...
Or I should say, not to the variable, not to the delegate.
It's to the whole signature is what you care about, right? Because then you could do the multiply one like we talked about earlier. You'd have public int multiply, and then, int1 and int2 inside the signature. And then that way, you could pass either addition or multiply in there. It doesn't care because they have the same signature, and whatever is going to execute that on the other end, it doesn't care. It just knows what the signatures are.
But it kind of looks weird, though, like if in that variable example, because then you just see, like, hey, I created some variable, and like in my example, I called it Adam, right? And now I'm going to say Adam, and then parentheses, 3,5.
Yeah, you might call a delegate something like...
So it looks kind of weird because now it's a variable, but instead of accessing it like you would every other variable that you've ever used, right? Instead, you're going to throw some parentheses on it and do stuff.
Yeah.
You're pass in values.
Yep.
And then there's some really cool C# compiler tricks that enable that to happen, which we're going to talk about in a little bit. But there's definitely some sugary magic going on there.
All right, so we already covered the callbacks, the closures. Did we hit this part here?
Yeah, I think we've already talked about it being big part of Link.
Yep, and I just wanted to mention there again with Link, a big part of what we kind of think of as Link is being basically built around anonymous methods, which are in fact delegates. When you think about that where clause example we gave, you do the whole like X arrow, and then you need to do something that returns true or false. What's going on there in the background is that you've basically got a method there that takes in a type of T and returns a true or false. So that's all the information that you need in order to do that where clause, and you don't actually see that nasty delegate word. There's no handlers there. There's none of that weird stuff. It's just a couple of crazy characters.
All right, so I don't think we've talked about this. What are handlers?
My brain explodes whenever I see the word handler. I never know if that's the one that does the work or like it's the one that kind of hands off the work.
It handles the work.
So it doesn't actually do it.
Right.
Okay.
Yeah, because the doing part of this whole thing is the event. The event does something, or not the event. Whatever's being called does some things, and then you fire off the event. You basically say, hey, I'm done, right? And then the handler is what takes over from there, right?
So did we mention that delegates were just another class, another object, another type?
We haven't gotten into that yet.
Because that's kind of key here, which kind of like that really would explain well what Alan's talking about. So like, we've talked about objects, inheriting from system.object, and that's what delegate is. It's another type that inherits from that.
It gets translated to that on compile.
Well, I thought it actually inherited from system.object.
So the delegate class does, but when you use that delegate keyword, it starts getting pretty confusing. So the delegate keyword does not define a class.
Right.
That just kind of happens in the background. And we do have a section coming up where we're going to kind of talk about like how this actually works underneath the covers. This is such a hard thing to talk about.
Yeah, so
I see where you're going with it, though.
But yeah, with the handler, basically, think of your on-click, right? Your button, probably the simplest state. So when you actually click the button, that fires off an event. That event is going to be click. Your handler is your on-click method that you created that says, hey, when this event gets raised, I now need to do something. So that's what your handler is. It's actually the method that is going to respond to some event that gets.
I guess the point that I was
raised.
trying to make, though, is that like there's an object type that has some list of methods to call and an order in which it plans to call them, right? And when you call that guy, that object is the one that is responsible for delegating who to call now. Right?
Okay, so that's a good way of remembering who the handler is. It's the guy who has the iterator, right? It's the guy who keeps that list.
That's the way I was trying to think of it, yes.
Okay, it's the class that keeps that list. Okay, I like that.
So let's get into events.
Yeah.
Those are parties or meetups.
Right,
or,
there we go. Yep.
Oh.
PlayStation
Sorry.
parties.
Wrong kind of event.
Maybe.
LAN parties.
Something that our listeners could probably associate with better. Yeah, so I guess the first part is we're going to talk about multicasting, which we've already somewhat stepped on a little while ago.
Yeah, but while we're here, whenever I think about events, I always end up thinking about the stupid null checking. And what that means is like when you got an event like I talked a little bit about the game I was working on, like I have an event for on player death. And I attach stuff like play a sound, play an animation, write some text to screen, throw up the start over dialogue, that sort of stuff. And those are all things that are attached to this event. But if none of those events are attached, if we imagine those not being there, and you try to say, call this on player death, then you get a null exception because that list doesn't exist without any items in it. That's
where you could use maybe of T.
Maybe of T, that's right. So what ends up happening...
I was actually thinking of like a AOP.
Yeah. Well, what ends up happening here is because they don't use this null object pattern, which we talked about in other episodes, is every time you see something like on before render or some sort of on event like on load, there is always this stupid little like if on load is not equal to null, then call on load with arguments, and so it just ends up being those extra couple lines there.
Yeah,
I guess that's how you know if you're dealing with a callback versus an event, because in practice it seems like it's always, if it's an event, like you're always saying like if
It's not null.
on button click is not null,
Yeah.
then on button click,
Right.
Yeah.
parentheses, semicolon, right?
Would you ever really want a callback that was nullable though?
Well, I'm not saying that you would. I'm not saying that you wouldn't also do it. But
But you
I guess
will
what I'm
see an
saying is,
event
like,
that way.
in practice, though, because you expect that callback is being provided, maybe not.
Yeah.
I was thinking, like, because you expect it's there, then it's not. Forget it.
Yeah, basically what we're getting at here is even though you see an event handler defined, it doesn't mean you can just call it. You've got to check to see if there's anything in it. And unfortunately, the way you do that is you say, "Hey, is it null?" Which doesn't make a lot of sense.
Could
But
you pass in null as a parameter, though? I guess
you probably could.
Yeah.
Yeah, you could. But you wouldn't typically
never
make
tried
a
it.
practice
Don't
of
do
that.
that. Don't do that.
Yeah, you shouldn't. But most classes are nullable by default. So yeah, you could.
Right, and it's one of those things like a lot of times you hear it's good practice to initialize your lists in classes, and that's so people don't have to check if something's null before they wear it or do some sort of other event on it. So it's just really annoying to have those null checks everywhere. Although I suppose it's safer and it shows that you're thinking defensively or some crap.
You care. All right.
Ugh.
So the observer pattern.
Yeah, we mentioned that these have a role with observers, and so this kind of ties into multicasting as well. But you can actually attach and detach these event handlers to the events that you're calling. So, like on that player death, I've got the sound system listening for that event. I have the text writing class listening to that system. I've got other stuff listening to that event, and so I can attach and detach those. And when that event happens, then they can all kind of take the appropriate action based on that. And that's basically the definition of the observer pattern, which we've talked about before.
Yeah, and the beauty behind that is you're not tightly coupling all those classes by doing that. You have something that raises these events, and the only thing that these objects have to be aware of is whatever is raising that event.
Yep. And so if I want to take this game into Unity and do some crazy 3D type stuff, I can do that. If I want to have it be a console game, I can do that too. And there's no sound playing or animations playing there. So it's just a good way of keeping the class that's doing this stuff and handling or not. Got to watch those words. That's actually throwing the on player death event. It doesn't have to know anything about what's using that.
Right.
There's a nice separation there.
And that's kind of your open-close principle that we just described again.
Yep. So there's some really gross stuff there too with event handlers. When I say event handler in this case, I literally mean there's a class called event handler that you can kind of pass these delegates into, and this is very like C# kind of 1.0 type stuff, and it also ties into those. I'm sure you've seen those if you're doing like on button clicks where it's like it takes the arguments are an object and event args. And you always cast the object to something, and you cast the event args, and you try to do something with it. And for a long time, that was kind of like the standard. And it's all of those things all derive from this event handler class. And it's definitely an old school way of doing things. And it's just gross to be doing this sort of casting and stuff. You're losing the type safety that you get from using delegates. That's one of the strong points about it. So I'm not a big fan of this pattern. And it's definitely kind of been phased out.
I don't think so. A couple things with that. I don't think we have anywhere in our notes where we talk about event handlers, do we? Not further down, I don't think. So a couple of things that are kind of interesting. In the old, like you mentioned, in the 1.0 days, you would have to define your delegate, then you'd have to define your event handler, and then you could start adding these things to them. In the, I don't know what version they changed this in, but you can actually just define the event handler without actually defining the delegate, which is kind of interesting. So they kind of allowed you to skip a step because they're like, if you're using a handler, you have to have a delegate out there.
Well, I guess it's important to say, too, like if you expect this to be multicast, then you should be doing plus equal.
Yes.
When you
don't do
whatever variable is going to represent the handler, you should be plus equaling when you add additional methods into it.
Yeah, so to further that and explain why. So let's say that you have this, I don't want to call it a global thing, but let's say you have this parent event bus type thing that you've got that is raising these events and all that, right? If you have multiple classes out there that are responding to these events, if you say that, this event handler equals, and then you give yours, you just blew away all the other event listeners out there, all the handlers out there. Interestingly enough, though, you can also do a minus equals. So if you have something to where, like, maybe you want to listen for an event until some state is reached, right? Like in your case, you're talking about your video game, right? Like once your player dies, there's no reason for it to be listening for these various other events, right?
Or hey, while you're on level 1.
Yeah, that's a perfect example. You're on level 1. If something happens, then this event gets raised. You're going to respond to it with one of your handlers. If you progress to level 2 now, you might minus equal your level 1 handler, right? So you can minus equals, you can plus equals. You can also do an equals, but you'll blow away everything else that was set up before. So when you're doing event handlers, if you're not seeing plus equals or minus equals, it's probably not right, and you're probably going to see some bugs.
Yeah, but it's nice too. I use it for sound, so I can turn off sound, and then I just don't, that sound system's not listening for events, and that keeps me from having to say, if sound's on, play sound all over the place.
Oh, yeah, because you just raise an event when something happens, and then the sound will play if it's on.
Yep.
Yeah, it's beautiful.
Yep, so just to kind of recap on those event handlers, it's basically just the kind of parent class for all those, anytime you see that object and event args getting passed around. And that's important later. We're going to end up coming back to this a little bit. All right, so we gave some examples from the .NET framework. I want to talk a little bit about delegates and other languages.
Yeah, so because I like JavaScript, we can talk about it there. It's weird to actually have this discussion in C# when I've been doing JavaScript so long that JavaScript just treats everything the same. Like, it doesn't matter whether it's a string, a number, a method, it doesn't care. So delegates in JavaScript are super easy. You just pass a function in as a parameter, or you can pass it in as a variable on an object. It doesn't matter. You can create your own object, open up a new object thing, do A: function, B: function, C: function, and then, whatever's getting that can just call, object.c, open, close paren, and you basically have a delegate. Or actually, it's not even really a delegate. It's just an anonymous function. It has no name. You can't call it any other way. So in that regard, it's not.
But the fact that you could pass it.
You can pass it.
So the fact that you could do like whatever your variable was .c.
But it's not I guess it is kind of a pointer because it's pointing by reference. But yeah, I mean, it's just such a part of the language that it's you don't even really think about it.
Yeah, you take it for granted.
Yeah, I mean, all the code that you do in JavaScript, you're probably doing some
That's why I was
version
kind of
of this.
laughing when you were talking about like one of your declarations how to set up the delegate, and I'm like, no, you just have like whatever your variable is, function space. Parentheses,
and that's because we are JavaScript monkeys now.
Curly brace.
Right. And actually, speaking of JavaScript, I think that basically anonymous functions are a huge part of the whole like jQuery revolution. And this is a lot of the first times that people really started using these kind of higher order functions. And when they started when jQuery got really popular, because you would basically do like dot selector dot each, and then you would do something in there, and you would basically just write an anonymous function, and it would get called inside of that iterator. So it became really big, and people just take it for granted now. In JavaScript, it just kind of comes naturally.
It's shocking to me that Java has not brought this in, considering like how pervasive.
Well, before we get into Java, I almost think that totally tangent. But I almost think like the anonymous functions are a little overused in JavaScript.
Oh yeah. Totally, 100%, no question.
Callback hell, quote unquote.
Yeah,
way overused.
It's really interesting. I mean, having coded in it for so long, you definitely just find yourself doing that.
I'm sure someone
time.
a lot smarter than me though can argue that no, it's done exactly the amount of times needed.
Yeah, and jQuery, it absolutely brought closures to the forefront. I remember when jQuery first started getting popular, and like every single blog article that you would see in your Google Reader was about closures.
Yeah, and wrapping your mind around that the first time is definitely painful.
Yeah.
Now, I do want to talk real quick, though, seeing as how we brought up other languages with JavaScript, like events. This is where using a library really becomes important, because when you start looking at how it's done, depending on your browser, you'll either be calling fire event or dispatch event. Like we still have that separation of browsers where they all do things slightly differently. So if you're not using something like jQuery or, God knows one of the other umpteen thousand, like I've done Dojo, EXTJS, they all have their own custom event system, but it's handled very much like what we're talking about in C# to where you define this event and then you can raise that event and other items or objects or components or whatever can listen on those events, and then they can respond to them with their own handlers, whether it be an anonymous function or whether it's some name function out there that's being passed around. So, all that, I find that JavaScript is closer to C# in that regard than what Java is, which, we started looking before the show trying to find, how did they handle this? And there were some pretty long articles on how they try to accomplish it, but they don't actually have anything built in for it. So, we may get blasted on this. Like, you're wrong in Java 8.234. I don't know, but
I used the Ask toolbar that came with Java, and it said,
"Oh God, don't get me started on that."
Ask toolbar. Just got me thinking like what the kind of the most popular higher order or first class function or delegate or function pointer might be in I was thinking document.onload in JavaScript. That's a great example of calling basically a variable or a method as a variable.
Yep.
And Java is weird on this situation. So they've got this in the 8. They've got this weird kind of single method interface implementation that allows them to get around not having two delegates, and they've got this thing called a method reference too, which is just kind of weird. But when we were kind of like looking at this, we talked before the show like what would we do if we didn't have delegates in C#, and then we Googled like, what does Java have instead of delegates? And it was basically the scenarios that we'd come up with to solve not having generics. And it was a pitiful, sad world.
Not having generics or not having delegates?
Sorry, delegates.
Delegates, yeah. And if C# did not have them, I would just code Node.js.
There's some callbacks for you.
That's what I would do.
So just real quick, wanted to mention that this is kind of the first part of the show. So we talked a little bit about delegates, events, and their role in C#, and also we gave some examples in other languages. All
right, so with that, let's take a little breather for a minute, because I think it's time that we say to everyone that has taken the time to give us a review and go out and give us a rating, how much we greatly appreciate that. And if you haven't already, we would love for you to do so. So Alan, it was codingblocks.net/review.
Yeah, or reviews.
Okay, fine.
You can do either.
Check.
No, you can.
Oh, really? You did both?
I did.
Look at that.
Yeah, man. I know how to set up some redirects.
Yeah.
Oh, yeah. And I totally on this /review page, I totally put some experimental stuff on there that I've never messed with before, like. There's click buttons to follow us on Twitter and Facebook and share.
You never use that?
On LinkedIn. Man, I've never coded this stuff. So I was out all over the internet grabbing this. It might work. Yeah, we're talking about technology that's 5 or 6 years old, but much like yourself, I'm not a socialite online.
How old is Facebook now? I don't like Facebook, but I've done a Facebook button.
Well, you're special. I should have made you do this page.
Apparently.
So, at any rate, yeah, there's all that kind of stuff on there. So, if you would, seriously, we love the reviews. We all are IMing each other. Dude, did you see the latest on Stitcher? So, it's awesome. It gets us excited, and it helps other people find it so that, you are basically making the world a better programming place for you.
And look at it this way. If you share the show with your friends, then it gives you something to talk about during lunch or whenever, that you can talk about like how much more right you are than we were.
Yeah.
Like how wrong was Michael when he was talking about delegates?
Yeah, totally.
And as a measure of that appreciation, reminding you again about the giveaway. So leave a comment on episode 24, and we will send you a book.
Yep.
It's a first edition, so...
Only edition.
Also,
way to belittle it.
We should have mentioned before we spend some time asking reviews that the episode is not actually over yet. So that was not. This is not the end of the episode. We still have some stuff we want to do. Share with you
keep
guys.
going. Don't hang up yet. Hopefully, you looked down and you saw that there was still half a bar left. Right?
They were like, "Oh, they're begging again." Click.
All right.
Listen to how you really feel. All right, so now we want to talk about a delegate deep dive. It's basically we want to talk about how this works under the covers. So who wants to dive into that?
Get it rolling, Jay-Z.
I vote you, man.
All right, so Michael mentioned this earlier, but basically at compile time, the C# compiler goes and it creates a subclass of this multicast delegate object that we talked about. And the multicast delegate object is kind of interesting. It's a class that, we mentioned that delegates are basically function pointers with an iterator. And that iterator is what the multicast kind of refers to. That's what the multicast delegate adds over just the normal delegate class. And the delegate actually is one of the few objects that derives directly from object. So it's not a value type, it's not a reference type, it's a type of delegate. So it's really a core feature of the .NET framework. And these delegates have kind of four methods that we wanted to mention. They only have four. One is the constructor.
Wait. Before you go there, though, I think it's important to note, though, that there's no intelligence behind this
What we
multicast iteration. Okay, yeah, that too. But the iteration, it's literally first in...
LIFO?
I don't remember if it's LIFO or whatever, but it's sequential.
It'd be FIFO.
Is it FIFO?
First in, first out.
I think it is first in, first out, yes. So, I mean, it's literally just, hey, if you added 10, whatever order those 10 were added in is the 10 that it's going to get executed in that same exact order. All right, back to four methods constructor.
Yep.
Well,
so
I was going to also add to the multicast definition, though, that it's important to note that there's it's a delegate that can have more than, according to Microsoft, a delegate that can have more than one element in its invocation list.
Right, and that's where the multicast kind of separates from just the delegate. So pretty much anything you're going to do is going to end up extending this multicast delegate, but there's still that kind of weird separation. So just kind of interesting. I don't know if they've got future plans for that, or they thought maybe they would do something else and it just didn't happen. But either way, you're going to end up
I think
extending multicast.
It was the latter, though, right? They originally had planned on it going one way, and then it just only ever became that one because it's been like that since the early days.
A long time ago, yeah. So either which way, you're doing multicast delegate, whether you know it or not, or like it or not.
Yeah, and
care?
so what that means is no.
No.
What that means is that when you write delegate, you don't even have a choice. There's no way to specify one or the other. You write a delegate or anonymous method, and in the background, the compiler will go and it will create an instance of this multicast delegate object. And it's got four methods. One is a constructor, so that kind of doesn't really count. But it's got an invoke, which just executes the method. And it's also got a begin invoke and an end invoke, which is useful in like async operations where you want to kind of kick it off and then, call some sort of callback when it's done. And so, and that wanted to call this out specifically because we're talking about like what Java guys end up having to do, which is basically like if you didn't have delegates, how you would handle a situation where you want to take a different algorithm or a different method in this variable is you would create some sort of interface that has a method like execute, and then you would create classes, called like add executor or multiply executor, and these would do your addition or subtraction, going back to that example that Alan gave. And then you would have a method that takes in one of these classes with that interface, and then you would just call that very explicitly. So what that ends up meaning is you create a class for every different operation that you want to do, which is a lot of typing. And that's really what's happening in the background. So really this is just kind of a sugary type thing. And the compiler just does that, that typing for you.
Yeah, I mean, it's kind of cool. It literally creates new classes for every one of them, all these targets and everything else. Like, you never see it. It's just real easy for you to do, but the Java people have to type it out. Like, everything that the compiler is doing for you here, they'd literally have to write that code to make the same thing happen.
Yep. And I want to mention that there were 4 methods and there were 3 private fields. And kind of the point I'm getting there is that it's really simple. There's not a whole lot going on here. So when you think about it from this direction, for me at least, it kind of makes things make a lot more sense. And Those fields were the target, which is basically the thing that this method is being called on, or if it's static, it'll be null. There's the method pointer, which is actually like the address of the function that's going to get called. So this is like the real deal. This is like the that method variable that we're talking about. And then there's the invocation list, which is like what we're talking about too with the multicast delegates, the list of things that this is going to happen on.
I did want to say though that like I guess you said something about the way Java handled it a minute ago that kind of struck me as odd. And I guess the only thing I wanted to say to that, though, is that Java, because they don't have delegates specifically or something like this, they get around it through, let's just say, creative uses of interfaces.
Right. Yeah, they've got this weird interface that can have a single method implementation, which is how they kind of get their lambdas in Java 8. But I'm definitely not an expert there, so...
But even before that, even before Java 8, though, right? I mean, they still handled it as interfaces, though.
Yeah, and that's the way I would do it too. So, like in the kind of the chess example, I would have a class called or I would have an interface called chess strategy, and then I would have a.
Not if you're in Java, you wouldn't.
Oh, yeah, you're right.
It'd be chess strategy impl.
No, that would be the implementation.
That'd be the implementation,
right? But so I would have an interface called chess strategy, and then I would have a class called like Bobby Fischer strategy, and it would behave in some ways. It would basically implement that the method, we'll call it execute, that's defined in that interface that takes in like the game board and returns some sort of move to make.
So I guess a way to sum up that difference though would be that if we're talking specifically C# to Java, right? C# tries to give special meanings to these, but really under the covers they're just normal types. Whereas in Java, the developer is more exposed to the fact that hey, this is just a type.
Yeah, they have to type it all out. Like
I'm not talking
very
about when I say type, I didn't mean typing, but I meant like they're more aware of the fact that it's an interface and the fact that it's a concrete type behind there. Whereas in C#, for example, there's this abstraction that's taken away from the developer, him or herself, by use of this keyword, and then the compiler does some magic to create this type that inherits from Multicast Delegate and does some magic for you.
It's totally a nicety. I mean,
oh yeah, and imagine if thinking about link, like every time you did a for each or a where or a first or default, you had to define a class with a method that took in the appropriate argument and returned the appropriate return value.
It's almost like having DTOs for all the internal stuff you're doing, right? Like you create DTOs for the way that you want to transform data coming back from a call or something. Now you got to do that for every single delegate like thing that you want to do. I mean, it's just a lot more verbose.
Yeah. To which I say, blah.
I just didn't want it to sound like we were bashing on it.
No, because it's just they don't have that syntactic sugar, right? Like they don't.
But my point is that like you can get away without it.
Yes, you totally can.
It is completely possible to do away without it because there's nothing
it's sugary,
crazy
definitely
going on.
Yeah.
But it's that sugar that buys you link.
Yes.
So there wouldn't be link without this. Like you can have lambdas in Java, but they're still pretty nasty, and it's basically doing that whole interface trick, which I don't know a whole lot about, but it smells kind of fishy to me.
Sorry for that derailment. I just wanted to comment on that.
Yep. Oh yeah. Also, wanted to tie back to earlier. Michael mentioned when you can kind of call this this delegate by just adding a parentheses and the arguments afterwards. When you do that, the compiler actually sees it. And it swaps that class that it created in the background, and basically does a generated class dot invoke and then passes your method, which is what you do with I think it's called method info or method information class in C#, where you can kind of dynamically specify and then dot invoke a method. And it's basically just metadata about the method. So that's the last part of the sugar there. And the last part. Oh
no, go ahead.
Wanted to mention we kind of tied the. This might be the only episode where we said we would get to something, and we actually kind of got to it. So pat on the back, guys.
All right, and with that, we'll be wrapping up.
Well, we mentioned event handlers and how I dislike them, and what I wanted to kind of tie back there was the event handler is basically a class that returns void and or it's it specifies a method that returns void and takes in an object for sender and event args e. And so a lot of the kind of legacy .NET stuff you'll see, it's got these events like on button click or on whatever, and you don't see the word delegate anywhere, and it's because these are all deriving from this event handler situation. And what happened is in around .NET 3.5, when they added anonymous methods and generics, they created these two classes called func and action. And these are amazing. And well, I know we're going to end up talking about these again in the future, but basically the difference...
We're about to get funky.
About to get funky. These both are heavily genericized methods. In fact, there's not classes. There's not a whole lot to them other than their generics, in fact. And so what I mean by that is that func takes in, at simplest case, a type and a result, right? So that'll be specified
an
in
input
characters.
type and a return type.
There you go. Thank you.
Yes.
Right. Yeah, at its simplest, right? And so what that means is I can say that my class is a func, and the input type is a string, and the output is integer, and I can have a method that converts between them.
Well, let's not say class. Let's just say like you were talking within a method, and you had some variable, and that variable was a func of
right. And so like the where example in link, that takes in a func. So you do your little X arrow, and what's happening in the background is this is getting cast to this func T result, and the T in this example is going to be whatever the type of that collection is, and the result in the where example is always going to be a Boolean. So in order to fulfill that kind of the promise in that signature, you say I'm taking in some sort of item in this list, and I'm returning true or false, which basically meets that kind of where criteria.
Okay, so let me maybe be too verbose. So going back to our calculator example that we did from earlier when we were talking specifically about the delegates, if we were to reimagine this as just some variable inside of your method, right? Then let's say that you had your add variable, okay? And the type of it is func, and then in your alligators, int, comma, int, comma, int. All right. So the first two ints are inputs, and the last int you're saying is the return type. Okay.
Right.
So func, int, 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 and then my variable name add. Right. And then I'm going to say equals, and then in parentheses I'll say x, comma, y, because I'm going to pass those into, and then my
equals then, greater than.
Yeah, my goes to. And then in there, I could have curly braces to say return x plus y.
Yep.
Right? And that's a simple example of using func of t in line as a variable, right? And now that I have this add method, or let me rephrase that. Now that I have this add variable, and I've declared it as a func of t, I could then later say something like a console.writeLine add, and then in parentheses 3, 5, yep. And it would return. I would see it write out the number 8.
Yep.
Yep. Totally.
And so going back to what he said though in the where clause, like in the link example .where, if you ever mouse over that in Visual Studio and you're not aware of what func of t is, it's confusing.
Yeah, it looks terrible.
Yeah, you'll have no idea what you're looking at. But the important part is whatever's on the left side of your lambda. So like he said, x, and then you have your equal and then greater than. X is your input, right? So basically your func of t is now, open bracket or open alligator, let's say 5, and then let's do a comma too. So you're going to get the int, same type thing that you were talking about. And now essentially whatever's on the far right side of that parameter list inside your alligators, that's always your return type. So if you look at it, all the inputs are on the left of that equals then, greater than, and whatever's on the right-hand side is what gets returned out. And it only makes sense if you actually understand what func of t is, which, you guys just explained really well. So the next time you look in there and you see this big, nasty, long thing on your IntelliSense, and it's like, this is it, you now know.
Or your IntelliNonsense.
Yeah,
I can't help but think of, like, anytime we talk about func of t, though, I can't help but think of George Clinton and the Parliament Funkadelic.
Oh, very nice.
So did we mention, though, that, like, well, what if, so in the func of t, you were passing in, you're saying, here's the two inputs and an output, but if you didn't need an output, then that's where action of t would come in. And I don't know that we really gave action of t as much conversation as func of t.
Right.
Well, we haven't got there yet.
Okay, well, I'm sorry, but I'm going to skip ahead. But it's basically like the similar concept, except without the result. So, in your, that add example that I gave, if you weren't expecting back a result, maybe you wanted to say like print add as the variable, right? And so you'd have action of action, and then the alligators, int comma int, and then the variable name print add, which is a horrible name, and then equals, and then in the curly braces, or in the parentheses again, x comma y, and then the goes to, and then the curly braces, then it would actually do your console.writeLine, x plus y in there.
Yeah, and so the only difference between func and action is that func returns something. And then the specific reason we wanted to call this out in reference to delegates and aside from its interactions with link is how this is so much better than the old school event handlers. So in .NET 1.0, there was event handler, right? And it took in an object, it took in event args, and it returned void. Well, along came generics in 3.5, and suddenly someone had the right idea, like, why are we kind of tying ourselves to this, object casting event args garbage? Why don't we just create this func in action, or reuse this func in action, and go ahead and create different versions of func in action that take up to, a very large number of arguments, up to 18 T's, generic types, and just use those instead. And what this bought us was completely strongly typed delegates. No more casting, no more event args, no more event handler.
And for anyone that wants to not think so highly of that, anytime you do strongly typed, then it's much better to fail at compile time than it is to fail at runtime.
Absolutely.
Pansies.
So if you hear me complain about JavaScript. So with that...
Yeah, so the interesting thing of what they both just said is, so first, the up to 18. What he means is, when you open up that alligator thing after the action or the func, that means you can do up to 18 inputs or 17 inputs with one return, right?
Right. And what that means is that any function that you've got, just like any regular method,
anything
that has up to 18 arguments, that is now a representative of this func class, right? And any action that has up to 18, so any method that you have that returns void and takes up to 18 arguments is now an action type.
I've never tried this, but I wonder, like, if you're going back to like a link type scenario, if you could ever get into a scenario where you would have, like, say, 19 or 20, do you get a compiler? What does it do?
I would imagine it'd have to fail.
You could still do it, but you can't use it as a delegate. So what would happen is, like, if you tried to do something where you passed it in, like a for each or something like that, or some sort of generic expression, you had 18 or more arguments, and it just wouldn't work because it doesn't represent a delegate at that point.
It's just its own class.
Well, I was thinking I
would think it would fail. Yeah, at compile time.
Yeah, so like if you think about that for each, it takes in.
Now I want to do some experimenting.
Right? Yeah, you could definitely see it. I think someone did online. There's a blog post we could probably link to. But what this means is, in practical, when I say that any method you have that's under 18 arguments can be treated as a delegate. So that means that any of these link expressions, as long as you match the right number of arguments, then or right type of generic, I guess you call them arguments, then all of a sudden you have embodied a delegate. And you don't have to use this delegate keyword anywhere. You don't have to set up any sort of handlers. It just, you got it for free. You're already an instance of func or action as long as you stay under 18 arguments.
Well, hold on. You still have handlers, but you don't have to assign any delegate things to them. You can just say handler plus equal, and then your func of t or whatever it is, right? You still need the handler.
Well, and like in a link expression, you don't specify a handler, right? You just kind of pop your method in there. And if you've ever seen like, you can pass a method group in there, so you can actually pass a method name. And the reason that works is because whatever method you specified, as long as it's under 18 arguments, can act as a delegate without having to be explicitly called that or typed that.
So you're talking about more lines with the link, not necessarily event handlers.
Right, yeah, events are kind of separate.
Yeah.
So.
Okay. I'm with you now. So what I was saying is if you are using event handlers in your code, you can actually do a plus equals and then just give it that lambda.
Right.
Which is the func of t or whatever. So that's what I was saying. What you were talking about is if you're using it elsewhere, like in a for each or whatever.
Right.
Then, okay.
Yeah, so imagine a case where you've got like a list of state names, right? And you say states dot select, and you do x arrow x dot lowercase, right? So what you're doing is you're getting a lowercase list of states back. Well, that lowercase method is defined in the C# framework, and it takes in a string and it returns a string. And because of that, it's acting as a delegate for func t result, where t is a string and the result is also a string.
Yep.
So these func actions really like open things up and pretty much killed event handlers.
Yeah, no, not event handlers.
Sorry, the event handler class. So that's the one with the object and the event args.
Okay.
I guess like even just, as we're talking here, just doing some quick Googling to see like, if there are other problems. There's definitely some, issues around like link to SQL, but it's actually kind of interesting because I'm not finding much for like, if I tried to do something with link that would try to take in too many. And now I want to try to do something.
But let's be clear: if you're doing more than 20 arguments,
yeah,
or 18,
they actually upped the number. I think when it originally came out, it was like 7 or something, and then a later version came out and went up to 18.
Yeah,
I guess what I was thinking of is like, is there some magic that happens behind the scenes to like break that up for you?
Well, he was saying there were hard to find classes.
Yeah. I know that there's the hard to find classes.
Yeah.
But what I'm saying is like, I don't even know like how I could write this example. Because I was trying to think of something like where maybe it was happening a little bit more dynamically that, where all of those values might get passed in, but then at runtime would it like break that up? I don't know.
What?
I'm thinking
theory,
out loud,
though,
and that's what.
If I was writing the compiler, in theory, though, because the compiler is smart enough to do the syntactic sugar, why wouldn't you just say, "Hey, what had the longest argument list?" And then I'll just create a class that has that, right? Like, I don't know.
Yeah, that kind of makes sense.
I don't know.
I was thinking the only kind of dynamic argument example I can think of is params, but really that just comes in as an array.
Yeah, it's an array, whatever the last X
so that
number.
wouldn't work either. But I mean, you see where I was going with that, though, right?
Yep.
But I don't know. I'll have to think about that because I'm trying to think about like how I could even write an example to see like because I'm guessing that there has to be some kind of error, but I've just never ran into it because like you said, if you're trying to pass in that many, then you have a problem.
Right.
Because you're never going to maintain it anyways.
That's never going to make it through code review.
Sounds like you need a builder pattern at that point. But
so before we get into the next section, I thought about these while we were talking about all this stuff. So when would you suggest using things like event handlers? So here's a perfect example of what I'm getting at. You can go crazy with this stuff, just like in the design patterns. And I think Joe jokingly said this in one of our design patterns podcasts was, when somebody picked up the design patterns book because all of a sudden you just start seeing all these patterns show up everywhere in code, right?
Factories.
Yeah. So here's the thing with events. I heard an example. Somebody said something like, let's say that you had an order system, right? And then somebody placed an order. Okay, there's certain things that have to happen after an order is placed. Like you're going to allocate some inventory. You're going to send an email out to the customer. You're going to, I don't know what else, right? Like, but would you would you go crazy with events, knowing that the whole reason they are so important is because it allows you to decouple your code, right? Like really, that's the most important part of event handling is, you can respond to something that is if somebody shouts out there fire, okay, somebody's going to go put out that fire, right? That's basically what happens in your code. When an event is raised, something responds to it. So would you do this in something like an order system? You brought up your video game earlier. When the player dies, you respond to that event. That seems like that's a perfect example of when you would use it.
I actually, I've kind of got away from events after my experiences with video games. And the kind of funny thing about it is that although the player is very much decoupled from the sound system, there's still somebody that knows a whole lot about players and sound systems and graphics and control systems. And what I found is that these kind of event touch points just ended up being the heart of my spaghetti code. So although these things were technically very separate, I'm also tying them together. So these things that are have no knowledge of each other suddenly are all combined. And so my problem there is that I started feeling like I was abusing these events to reach all over my code base rather than going through a nice clean hierarchy.
That's kind of interesting because, okay, let's take an example. And I think I brought this up earlier. Let's say that you had a UI that had, I don't know, 10 components that showed various different pieces of information about something. Let's say it's a person, right? Something on that person changed, like the first name. A very elegant way of handling this is whatever the parent component is, right? The thing that has all these other components out there, these 9 or 10 components on the page. It is what can raise events. And, it's basically your event bus for the whole thing. Or maybe it has some sort of implementation of an event bus, which you might do through a singleton or something else. But it raises an event. Those 9 or 10 different UI components can now say, oh, wait, the first name changed. I need to change my stuff, right? That seems a lot more elegant than saying, okay, this thing knows about that object. It's going to go over here and change that data. Then it's going to go change this, and it's going to change this. It seems like that's a lot more elegant than the alternative. You know what I'm saying? So, I mean, I can't think of a clean way to decouple that. If you have and let's say that you don't even know what those components are going to be. Maybe it's pluggable stuff, right? Like, how else would you do it?
Yeah, that's a good point. I know that for me, like when I started kind of doing the events, I kept finding myself doing more and more and more of them until I realized that I was basically just using them as glorified go-tos. But I do think you're right that I was keeping things separated, but it was allowing me to kind of jump across the object graph in kind of a strange way. So it just kind of started smelling to me, but maybe that was just me kind of doing bad things.
Interesting. What are your thoughts? So we've all worked in e-commerce software. Is this something that you think you would want to do on an order system? I mean, would you want, okay, order was placed, raise that event, order placed. All right, now it needs to go do something with the inventory. Now it needs to go send an email. Now it needs to do X, Y, and Z. Would you do it there? Or because typically the way you see it is order placed. All right, now it's going to just go to the next step and say, all right, deallocate some inventory. Now it's going to go to the next step and it's going to say, all right, send out an email. Now it's going to go do X, Y, and Z, right? Like it's usually a sequential, thing that you see in code. Whereas if you did the event thing, you decouple that. And then if you need to reuse that, because we've all run into this before, like something gets jacked up with an order somewhere and you need to send that email. It's all tightly coupled to something else, right? So you can't go send that email now without like writing code to somewhat hack into it. Whereas if you just had something that responded to an event like, hey, this order was placed, hey, send out an email. So I'm just wondering, like, would you ever take it to that step? I've never taken events. I have on UI, but I've never done it so much server-side type stuff.
Yeah, I could definitely see like using kind of different event queues there and kind of saying like, okay, order placed now, put it in the email queue, in the inventory queue, in the flash a red light queue, whatever. So yeah, that's definitely an interesting use case there, and it kind of separates all those systems. And so what it means is, if the email system's down, then everything else kind of still keeps going until we get that back up. And by having the queue there, it kind of prevents that action from not happening. or it saves that action.
You can fill it back up, right? Like it would be fairly trivial to do something like that at that point.
Yeah. It definitely comes in and help a lot of times with UIs, button click type stuff.
Yeah.
That's kind of like the prime examples of it. But yeah, in e-commerce, I think that works really well too.
I mean, I think it's one of those things.
It's hard to think about like from an abstract like that though, because I'm thinking like as you're talking, and I'm like, well, I mean, like I see where your intent is going, but then I'm like, well, then you have some kind of like event orchestrator, that's managing all those events, and then it's like, well, then it gets like then we go into this whole other tangent of conversation, because then it's like, well, are you really like solving the problem that you were talking about then? Because then you still have like it's all tied together in that whatever that's doing that orchestration. Versus what if you just made those each as like separate components? They just ran on their own kind of schedules or whatever. I don't know. It seems like that we're getting into like a really deep kind of conversation.
Maybe, maybe not. But so I mean, but I think it's helpful, right? Just because. Only from the perspective like this, like you can't just schedule something, because unless you do that and every part of the schedule starts setting up different states for these things, I guess you could do that, right? But then you still have an orchestrator. But what I'm saying is,
no, I mean, I was thinking like you could the email coupling, the emailing you mentioned as an example of, right, like that might be one of the events, but you could totally decouple that completely away, and like that could be its own little job that runs on its own. Maybe it runs in batch, and it just looks for orders in a particular state, and then does it like.
But you're still taking it to that step of abstracting. So basically what I'm saying is typically when you look at software, it does A, B, C, D, E, F, G, right? Like in that order. That's what we've mostly seen as programmers, right? And that's because that's how people think about the process when they're designing the software. Hey, when you do this, then this needs to happen. The next step is this. And that's usually the way you see it. It's just very sequential down the code. If you break it out into an event type thing to where you have, before order placed, order inventory allocated, email sent, whatever. Yeah. So what I'm saying is what you're describing is the same thing as an event bus, except now you're separating it out to where you have batch jobs that are going to key off some piece of data, right? Like you're going to say, okay, has the order been deallocated?
I say no. This is why we're getting too specific into like one kind of example though, because like, the thing that I don't like about what you were suggesting with putting this into...
wasn't suggesting, I was asking.
Okay. Well, in your example, into that example, then you still have the order of those event calls in the example that you gave is still within some other piece of code, whereas what I was suggesting is, well, what if you broke those out and they were intelligent enough on their own to say, these are the orders that are in a state that I should send out this particular kind of email about. And that's what I'm saying. Like, I think like this is getting way deep into a very specific kind of use case.
No, it is. It's very deep if you were to actually go down it. But I was just kind of curious about like,
yeah, I think you've got a valid point there with thinking about like events and like a kind of event queuing. You're talking about a system that basically deals with events, and you're thinking of it from like an architectural rather than kind of a programmatic view. And yeah, I think that's a very interesting thought.
Yeah.
All
right. So we kind of talked about the encapsulation aspect. I also wanted to mention this is kind of it almost seems a little bit silly, but are event calls asynchronous?
No.
Yeah,
I'm going with no.
Yeah, it's kind of a weird thing because your call, like if you think about that method being defined in the class somewhere, it kind of gets called at, in some different context, right? So you don't really know where that's going to happen. But yeah, the call absolutely does, unless you specifically say.
Well, here's the specific example that I was thinking of. Not a specific, the specific use case that I was thinking of is that in a lot of, did you say Call of Duty? In a lot of scenarios, you can actually halt the execution of that event, right? So you can say like, no need to go any further, and maybe that's on an exception.
You stop
as
propagation.
An example, right? Or whatever your use case might be.
But you could spawn it off onto another thread, but.
Yep. Same thing with kind of exceptions. You can catch it and stop the propagation.
Yeah,
right?
but the point though is that like if you had on button click and you have 5 handlers,
Yeah, it's
all
synchronous.
5 of those aren't happening
Right.
at the same time.
not
They're
parallel.
happening one after the other.
Yep.
And that goes back to our point about the invocation list within the multicast delegate. Like, as Alan said, it's just going down that list in order. There's no special, craziness
magic.
happening.
Yeah,
there's
it's an
nothing
iterator.
magical about what it's doing.
Yep.
It's literally walking down that list.
Yep. That said, though, delegates do factor a lot into like kind of the TPL, the task parallel library, and it's a big part of doing some of the kind of cool parallel kind of concurrency stuff that you can do in C#.
All right. So, wow, we talked a lot about delegates. Let's get into what were some resources that we liked as we got into it. Not everyone at once.
You did the CLR via C#, right?
Yes, absolutely. So that was
my God,
a
we've only talked
fantastic
about this
book.
book a couple times.
Yes.
When are you giving that one away?
So that one I actually already gave away. I let someone borrow it and I forgot to get it back when I left that job.
Was this at the doctor's?
No. Apparently, I'm not good with physical books, so that's why I'm giving them away.
Oh, okay.
But yeah, CLSCR, C# has an excellent chapter on delegates, so definitely recommend checking it out. It actually has a whole separate chapter just on methods, and a separate chapter on properties, and a separate chapter on fields, and it's the Bible for C#.
It is.
Yeah, and we've definitely talked about this book before. It's by Jeffrey Richter.
Yes.
I hope I pronounced that correct.
Yep.
Currently in its 4th edition, so it is an awesome book to have.
Yeah, also wanted to mention another book, C# in Depth, which did a really good job of, this is by John Ski, we've mentioned this one before too, but it did a great job of kind of running through the history of delegates and kind of like explaining some of the ways that kind of things started and how they ended up, and that kind of helps you understand why you'll see so many different kinds of examples on the internet.
Yep. One of the resources I liked whenever I was doing this, and I think Outlaw also, was the Pluralsight course on C#'s events and delegates by Dan Wallen. It was excellent.
Waylon?
Wallen? I can't remember it. He says it. Anyway, I said it both ways, so he's covered. But it was an excellent run through. He ties in some great examples. He shows you basically the evolution of delegates within C#. So nice resource.
Yeah, we've also got a nice link to MSDN, which you can find on the website.
Yeah, these will all be links within the show notes. So with that, let's wrap it up and get into the tip of the week. All right, so I had one, and then I decided maybe I should say another one, but I'll go for the first one. So I had found this. We've all used fiddles before. A lot of JavaScript fiddles that are out there, but there's .NET fiddle.net. If that's too much .NET for you. So the first .NET, just to be clear, is spelled out. So DOTNET fiddle, and then .NET as the top level domain. Great little site if you want to. Let's say you're on your Mac and you want to write some C# and see it compile and run and whatever. You can create your fiddles there. The reason why I say I had some kind of problem earlier, and I don't know if they were just doing some maintenance. I'm certainly not going to take credit for bringing them down, but I was writing a fiddle, and then suddenly things stopped working, so I wasn't sure. So I had a second tip, which is really awesome, which I'll include a link to it. But if you are a fan of Git, and if you use Git, and no matter what language you are coding in, there is a GitHub project for git ignore, for the one and only file. It has suggested git ignore statements for every language, every project type that you could think of. So specific to Visual Studio, for example, there's a Visual Studio.getIgnore that includes, ignoring your debug folders, your release folders, your various third-party plugins, NuGet packages, ReSharper, things like that. It is a fantastic way to start your GitHub, your Git repo. So we'll include links to both of those in the show notes.
Yep, and I wanted to mention another podcast. I like doing that, apparently. I think I jumped ahead of Alan there, too. Sorry.
No, you go ahead.
I was just doing some
You were so excited to talk
surfing.
about some other podcast.
You go ahead. I was typing.
Yeah, so I want to mention the Reply All podcast. This is a great podcast, and they talk about kind of like internet-y type stuff. It's almost like This American Life, but for more technical people. And some of the episodes have been about like interviewing a guy who's new to the internet, swatting you might have heard of. They've got a great interview with a wiki grammar enforcer who just...
So, wait a minute. They interviewed like a 2-year-old because he was new to the internet? Like,
no, someone who'd never used the internet
that's
before.
not possible.
Yeah,
You can't find that person.
It's not very many. One of my favorites is... it was the interview with the guy who... remember when Kim Kardashian broke the internet, quote unquote?
Okay.
Well, they had an interview with the guy who was in charge of getting that company's websites, web scale, so they could handle that kind of traffic when they expected it to blow up. So it's just a really good show, and I think it would be good for our audience.
Sounds like the opposite of a first world problem if you're trying to find someone who's not an infant and new to the internet.
They actually went to a third world country.
Did they really?
Yeah, I'm fairly certain. No,
I don't think so.
I don't know. Actually, well, no, never mind. So
I guess I'm a jerk for thinking like, whatever.
yeah. All right. So the one that I found while I was trying to build my little course that is turning into a big course was this fantastic thing in the Visual Studio library gallery or whatever. It's called Generic Unit of Work and Repositories. So if you've ever looked into repositories for separating your concerns with your data calls, this is an excellent way of doing it. So essentially you can use one of the free tools from Entity Framework, or not from Entity Framework, I think from Microsoft, for generating entity files. And then it'll set up your unit of work and your repository code for you. And it's fairly easy to use.
You talking about T4 generators?
No, it's not a T4. So
when you mentioned
the entity tool, no. So there's a tool that you can download from Microsoft that's a Visual Studio extension, and you can just right click a project and say, "Hey, create entities," and then you point it at the database, and it will actually go generate all your code. It's not using a T4 template, or at least I don't know if it is because it's an extension. But then after that, they've created these nice repositories and units of work that you can literally just hook up. They have iRepository asyncs, they have regular repository, they have services. Dude, it's pretty amazing the framework that this guy set up. And I think his name, I can't think of it right now. It was like Lee Long or something like that. But I'll have to.
Well, I hope you're right. Otherwise,
hold on. I will find it real quick.
Random name guess.
Yeah, go ahead, and I will find him real quick.
All right. So while he's doing that,
Long Lee.
Well, you was so close.
I was reversed, right? So, but no, this guy put it together, and it's absolutely killer.
All right. So hopefully you like the show. This episode we talked about delegates at events and a little bit about Link and how it all works underneath the hood. So hope you liked it. And yeah.
All right. So
be sure to subscribe to us on iTunes, Stitcher, and more using your favorite podcast app. And like we said before, be sure to give us a review. We do greatly appreciate that.
And contact us with a question or a topic. We definitely love getting the emails about topics. Leave your name and preferred method of shout out, website, Twitter, whatever, and we'll mention you on the podcast. And visit us at codingblocks.net, www.codingblocks.net, where you can find your show notes, examples, discussions, and more. And
send your feedback to
this particular episode will
race
be
condition
codingblocks.net/episode 24.
Yep, and send your feedback, questions, and rants to comments@codingblocks.net, and be sure to follow us on Twitter @codingblocks.